All right, someone give me a field where statistics would be useful. Anyone? Yep.
Economist.
Economist, totally. Someone else, something else. Economist.
Medical field?
Medical field, totally medical field, right? In so many different ways. Medical field, experiments, other things. Yes?
Data science?
What was that? Data science? Totally. Data science. Anyone else? Something else? Come on. Sports. Absolutely. Sports.
Space.
Space?
I don't know.
Like NASA?
Oh, NASA. Totally.
Yeah,
Right? They're not going to send up something without some data to work off of.
Marketing and sales?
Marketing. Totally marketing. There's something over there. Marketing. And over there?
Stockbrokers.
Stockbrokers. Definitely. Right? They need to make predictions. No one's mentioned my favorite one.
What's it called?
Gambling. Gambling's my favorite one. Gambling. I actually played poker for a living for 2 years. And honestly, I'd still be playing poker now if the economy hadn't tanked in 2009. Because it's fun. And right, you go there, you play poker, they give you free food wherever you want to eat. And it's a really cool life. And I got to play against Bruno Mars once, which was really kind of neat. I had no idea who he was. I just knew that everyone wanted to be on that table. And I talked to the foreman, he's like, yeah, Bruno Mars is on the table. I'm like, okay, get me on the table. So he got me on the table. I played, and he was super nice. And then I went home to I was staying with some friends, and I was like, yeah, I played with Bruno Mars. I don't know who he is. He's like, yes, you do. I'm like, no, I don't. And they played me some songs. I'm like, oh, yeah. Okay, here's some other things. Market research, medical field, government surveys, sports statistician, small business psychology. There's a lot of different areas that use statistics. So many. And then now, here's a new one that it's another big area that uses that, another big job opportunity for people. So now, as you guys probably realize, we have internet cookies, which you guys have probably heard of. Basically, it gathers lots of information about where you go, what sites you go to, what things you buy, blah, blah, blah. And it's what we call big data, where all this data is coming in from all these sources, and there's the job of sifting through all that data and finding some way of making money off of that is a really big job. Right? If you can find a way of making money off of that, then that's very good for you. So this one guy, a statistician, went into Target, and kind of what happened, what resulted, was this father versus Target. Father goes into Target, he's pissed off, and he's like, my daughter got this in the mail, she's still in high school, and you're sending her coupons for baby clothes and cribs. Are you trying to encourage her to get pregnant? And what's going on? And the manager's like, I'm so sorry, I have no idea how that happened, totally apologize, because something screwed up along the way, right? And then a few weeks later, or sometime later, the father contacted the guy again and said, I'm sorry, turns out you're right, my daughter really is pregnant. So Target knew before the father did that his daughter was pregnant. How did they know that? If you buy certain items by themselves in combination with each other, it increases the likelihood that you're pregnant. For example, if you buy unscented lotion and cotton balls and certain vitamin supplements, there might be like a 57% chance that you're pregnant. Right, if you buy like a yoga mat and like a big bag and there are like three other things with it, it went up to like a 68% chance that you're pregnant or something like that. In general, what's the likelihood you pick a woman and she's pregnant? Less than 1% or more than 1%? Less than 1%. All right, less than 1% of the women in the world are pregnant. Come on. So randomly, it's really hard to pick somebody and have them be pregnant. But if you can up that to even 25% and send out flyers and have a 25% chance that that person's pregnant, that really reduces your marketing costs, right? It makes you much more efficient in terms of marketing. And apparently, pregnant women spend a ton of money. So if you can get in the ground floor with a pregnant woman, then that's like big bucks. So that was a really good strategy this guy used to try to target and find a way of targeting pregnant women and identifying who pregnant women were by using this big data. So kind of neat how things are changing. We're going to talk about three different things we're going to do in statistics. The first thing is descriptive, where you compile data and you analyze it, and maybe you make a graph of it. So it's taking a survey and analyzing that data. And then there's inferential, which is making assumptions or predictions from that data. And then the last thing we're going to cover, the third kind of section, is probability, which is the best and coolest part, of course. I'd like you to think about a few things, just in general, in life. Think about, what does the data actually mean? What's going on? Don't just be focused on crunching the numbers and whatever, but what's actually happening? What's the goal of the study? Why are they even doing this whole thing? And then also be skeptical of the source, right? Is the source objective or is it biased? Very often it's biased. If it is biased, then really be vigilant and skeptical of the studies from them, because they tend to try to swing things in their favor whenever possible. All right, so now we're going to get on to our little handout. Does everybody have a handout? Does everybody have one of these sheets? Are there still some in the back? Okay, good. All right, so let's go ahead and get a reader for this one. Joseph G., go ahead. Read the first two.
Just the first two?
First two, yeah.
A variable is a characteristic or attribute that can assume different values. Data are values measured or observed for your variables.
Great. So a variable is something that can assume different values. For example, hair color, or college major, or your height, or your age. So it's something that you can ask people that could have different possible answers to it. The data are the actual answers to that question. So if hair color is your variable, then the data might be brown, black, blonde, black, brown, red, green, black, brown, right? The data are the answers you get from your survey. Keep going.
A population consists of all subjects, human or otherwise, that are studied. A sample is a group of subjects selected from the population, a subset of the population.
Terrific. So, say I want to know about community college students in California. I might randomly sample a bunch of people from Las Positas College, and Las Positas College would be my sample. Community college students in California would be my population. But say I want to know about Las Positas College students, then Las Positas College students would become my population, and I would take a sample of Las Positas students, and that would be my sample. Do you see what I'm saying? So your population is whatever you want to know about. If I want to know about all Las Positas College students, then they would be my population. And if I want to know about a wider group, then it kind of depends on who you want to know about. With your partner, let's get a reader actually. Rakaya, go ahead and read it.
Oh, read this.
Yeah.
With your partner, answer the questions. A study at Community College X looked at a random sample of students and found that students who attended class 95% to 100% of the time usually received an A in the class. Students attending 80 to 90% usually got a B or a C, and students attending less than 80% usually got a D or an F.
So with your neighbors, answer these three questions. By what are the data under the study? I mean, what? Give me some examples of possible data. Okay, go ahead.
The times, the percentage, the grade, right? And then what's the last one? Students. This variable is my great. It's a variable. I'm never speaking or anything. It's like the population of students. The variable is It's the
Data value.
I think those numbers we see.
So you want to know what yeah, great. So data is the hard numbers. Variables and
So for variables, you want to ask yourself, what am I asking this person about themselves? What things do I want to know about any of my sample subjects? Okay, so here's somebody who I'm sampling. What two things am I asking myself about him? What two things do I need to know about him?
Does he attend attendance?
His attendance. What's the other thing? His grade. So those are my two variables. So everyone follow? Grades and attendance. What are the data in the study? What's the sample of possible data in the study?
the data is the percentages.
Uh-huh. So the grades, so for example, my data might be A, B, D, A, C, is that kind of follow? And then for the attendance, it might be like 90%, 95%,
68.
68%, sure, 74%, they're totally not passing. All right. And then what's the population under study?
Is it the community college?
Right, so you could either say all community college students, or you might be more specific and say community college X students. Either one of those is totally acceptable for today. Good? All right.
Would the subject be like the individual themselves?
Yes, so your sample are the people that you asked, but your population is who they represent. So as a whole, they are a sample of all community college X students. So you really want to know about all community college X students, or maybe you want to know about all community college students in general. Right? So you're not be asking them, thinking, oh, they're a pretty good sample of community college students. So you can do that. Might be a little bit biased, but. Juan J, go ahead. Statistic? Juan Jimenez?
I wasn't paying attention. What was the question?
Can you read this?
Just read it.
Mm-hmm.
A statistic is a characteristic or measure obtained using the data value from a sample. Perimeter is a characteristic or measure obtained by using all the data value for a specific population.
Okay. So first we have a statistic. That is something that belongs to a sample. So like a mean is basically an average. So if I wanted to know my sample average or my sample mean, that would be a statistic. My sample standard deviation, that would also be a statistic. My sample proportion, right? I sampled 25 people, 32% of them ride a bike. That would be a statistic. A parameter is a characteristic that describes the whole population. It uses all the data values. Very rarely do we know all the data values, only census, right? This class is not called parameters. This class is called statistics. Why? Because it's easier to take a sample and then make a guess about the population from it. So we take a statistic, like we take a sample and we get a sample mean, a sample average, and then we might guess that the population mean, the population parameter, population mean would be about the same. So we take a sample, from that we get a statistic, and very often we're guessing that the population parameter, which would be the population mean or the population standard deviation, the population proportion, is similar to our statistic. So don't freak out. Parameter is something that belongs to the population. The nice thing about it is you'll notice that S statistic, S sample. P population, P parameter. Those go together. When we say parameter, that's just a fancy word for meaning population something. Where you're talking about population mean, population. Which, you know what? Until we get to those, let's not even worry about that. Move on. Okay. Good. How about Sterling, Jay?
Descriptive statistics consists of the collection, organization, analysis, and presentation of data for samples. Inferential statistics consists of generalizing from samples to populations, determining relationships among variables, and making estimations or predictions using probability and hypothesis testing.
Right. So descriptive statistics, you take a sample, you analyze it, you have facts. Based upon your facts, you're giving descriptions about what happened. Descriptive statistics. It's describing what you got in your sample, what you found factually. Inferential is when you infer things, when you guess at things, when you predict things based upon your sample. So I'm guessing about the population based upon the fact of my sample. So if it's all about the facts, then it's descriptive. If you're making a guess or prediction, that's an inference. So it's about making estimations or predictions. Guessing. So why don't you guys talk to your neighbors and figure out whether each of those is descriptive or inferential.
So the average would be descriptive. I was thinking other ways.
Because it's a hard
Okay. The top 5. Okay, I agree with you. It's 5. I agree with you. That one, I would say for sure.
I thought it was.
That's a guess. Yeah, I would say it's and also because it's like it's hard to also like measure memory loss. You can't measure it. Just like older people who are high calorie diet. I don't know. It's just kind of like out there.
Yeah.
It's not really a hard number.
I think the word suggests.
All right, let's take a look at A and B first. So A, the average jackpot for top 5 lottery winners was blah, blah, blah million. Is that a fact or is that a guess? It's a fact. So is it descriptive or is it inferential? Descriptive. Okay, good. How about the next one? Study suggests that older people who had a high caloric descriptive, sorry, there we go. Who had a high caloric diet more than double the risk of memory loss. Is that a fact or is that a guess?
Yes.
Yeah, I'm older. They did not ask me. So they did not ask every older person in the world. So that would be it's a guess, so it would be inferential. All right, so why don't you guys finish up, give you guys another minute to finish up the rest of these. Please note that these are two different ones. So this is one, and this is a different one. Does that make sense? They're two different scenarios, slightly.
That's the number divided. This was a specific number, 9,000. But yeah, like, this is guessing. The scientists have also found that good last, like, infrared, right?
Yeah, infrared.
It's called infrared.
Yeah, because people actually didn't.
Okay, sounds like you guys.
Yeah, each person.
How about the next one?
Exactly, I agree.
Based upon a survey of 9,317 consumers, the average amount that these 9,317 consumers spent on Valentine's Day in 2011 was 116. Is that fact or is that a guess?
Fact.
Fact. So is that a descriptive or is that inferential?
Descriptive.
Descriptive. And last one, would change if I said all consumers. So based upon a survey of 9,000 consumers, the amount that all consumers in the United States spent on Valentine's Day in 2011 was $116. Is that fact or is that a guess?
Guess.
So is that inference or descriptive?
Inference.
Inference. And the last one, scientists in Oxford found that a good laugh significantly raises a person's pain level tolerance. Do they mean this one single person or do they mean all people's?
All.
They mean, yeah, they don't mean like this specific person that raised their tolerance. No, they mean like, it means a person, all of us as people. Is this a fact or is this a guess?
Guess.
It's a guess. They didn't ask, you guys are all people. Did they ask you guys?
Nope.
No. See what I'm saying? So yeah. So that would be inference. Let's take a 10-minute break. If you need, so come back at 1:45. If you need an ad code, come see me.
You have a Snapchat?
No, I don't.
You don't?
No, no.